Let's start problem 11 from chapter 5. Okay. All right. So it says the population of a southern city follows the exponential law. Use this information to answer parts A through B. And A says, if N is the population of the city and T is the time in years, express N as a function of T, and you need to see the instruction. Obviously for tomorrow as well, you need to take care of the instruction. Before starting solving the problem, you need to make sure you have seen the instruction. It's really important. So it says type an expression. What's that? Type an expression using T as the variable and in terms of E, okay? So first of all, our population is N, that's given. So you want to take N naught as the initial population, right? When T is 0, okay? So clearly, our equation will be N naught. Obviously, we need to use E as it satisfies or follows exponential law. It will have a T somewhere here, but next thing is to define the growth rate, okay? Or it could be a decay rate as well, but generally for a problem, we'll say it's a growth factor, okay? So we could denote this as K, or you can denote this as anything else, doesn't matter, as long as you know what it means, okay? So this should be your answer for A. All right, so that's A. Now let's go to B. Okay, B says if the population doubled in size over 22 months and the current population is 40,000, what will the population be in 4 years from now? Okay, so first of all, again, we have a clue that is N of 22. That means in 22 months, it will be exactly double of the initial population, okay? So double the initial population, that means 2 N naught. Okay, that's one of the clues we have. And next, we also have the current population is 40,000. Okay, so that's N naught, to be honest. I'm sorry. Yeah, that should be N naught. Let me erase this. Yeah, it should be N naught. Okay, all right. Now, the next thing is we are trying to find a time. No, we're trying to find N rather, not time. The time is given 4 years. So after 4 years, we are trying to find the population. So this way, if you can write this way, the clue you have, or I'd say the clues you have, the thing you need to find out, if you can figure this out, I guess if you can arrange this in this way, you can actually see what informations you have and what else you need to find, right? So now we can see, as we are trying to calculate N from the given equation, we know that we still need to find out K, because finally we want N, as you can see, we want N, okay? And we know T, which is given also, as you can see, that's 4 years. We also know n naught. So the only thing is missing is the value of k. Can you see that? If we somehow figure it out, if we can calculate k, we should be able to find out n. Okay, so let's do that. How can you do that? So n of 22 is 2n naught. We'll use this clue first. We also know what's the formula for n, which is n naught e to the k times t, right? T is 22 here. So I've written 22k. Do you agree? And of course, on my right, I had 2n naught. Okay, so now I can cancel out these n naughts. Okay, so excuse me. So e to the 22k will be 2. Now what should we do next from here? As you know, the next thing we need to do is to use this property, which is if you have anything like this, you can always write x equals a to the y, or vice versa, right? This means it goes both ways. It works both ways, right? So if we use that same property, obviously on my right, I'll have a ln because this will become my base. So if the base is e, we can straight away write a ln, right? And this 2 will come down here and we'll have a 22k, right? That's because that's my y. That's my y here. Okay. So clearly my k would be 1 over 22 times natural log of 2. Now again, if you have the calculator, you can find the approximate value and don't start rounding it until the final answer, as you can see in the instruction. Okay, so can anyone tell me the answer without rounding? What's the approximate value of this? Without rounding it? Okay, so let me write the first. Okay, so it will be 0.03. Oops, sorry. It would be 0.03 15 0669 002. Okay, so I think you can take up to this, yeah, because even if you don't round, it's approximately this. Yeah, you can take this. All right. So, but again, I would suggest you guys to take this value, okay, because you can use the calculator. So there is no reason that you can't use this. So it's better if you take this. Okay. Next, we want to calculate finally our desired value, right? Which is the population at time t. Now the next question would be what's t is? What is your t? What is the value of t? It's given 4 years. Should you take t equals 4? 48. Very good. Because if you have seen, initially we started taking t in terms of months. So we need to carry on doing that to have the consistency. So it will be t equals 48 instead, right? Not 4. Okay. It will be obviously in terms of months. Okay. All right, so n naught e to the k t, and now if I plug in the value, let's see what happens. N naught is 40,000, okay, and k is this, and if you multiply that by 48, can you tell me the answer? If you let's multiply 48 by this, multiply 48 by this, okay, can you tell me the value? Just use your calculator. 1.512. So 1.512. And what's the value of e to the 1.512? Just multiply 40,000 with that. Okay, so the value of this is 4.5357. So multiply 40,000 with that. Okay, 181,490. 181,490. And this is exactly the value that's been written in the answers. Can you see that? Right? Let me write this clearly. That's a 4. Okay, yeah. Okay, now any question from this? Any concerns? How did I get the value? What else can you do, etc., etc.? Any question? I didn't get that value when I plugged it in. What did you get? 181,428. I think that should still be all right. That should still be all right. But again, as I said, I would recommend you guys to use this. Don't take shorter values. Okay, as you can see, you got about 62 less than the original one. That's still okay. That's definitely within the range. But as I said, my suggestion would be use this. Don't round it. Take the entire value. As you can use the calculator, why take risk, right? So I'd suggest you guys to take that. All right. Okay. Would the test count it wrong? As I said, um, it does have a certain tolerance level. Okay, and you got only 62 less than the original one. So it seems to me that it should be all right, but I'm not sure. Again, that's why you need to see the instruction. Don't do anything, out of the box. Just do what it says you to do. Okay, that would be wiser to do. As it says, don't start rounding. So I can clearly take this. Why go for glory? Why take risk? So I don't think that you should anyone should approach that. As you can use the calculator, go for this. Why not? Separate question. Does ln e to the x mean log e? Okay, I'm not really sure what you actually meant there. Did you mean this and log e base e to the x? Did you mean like this? Okay, yeah, obviously, because as you can see, log based E is ln, and this is something that's true for each logarithm. So definitely they are equal. Either way will do. Whatever format you write, uh, either will do, definitely, yeah. Okay, what's next? Ten. Okay, so number 10. Why is 10? Okay, here we go. Okay, so number 10 is solve the equation ln e to the x equals 19. Okay, I'll take answers first. What do you think when you first see this problem? You know that you need to solve it, right? The question says solve it. What's the first thing comes into your mind? Excuse me. Okay, the 2e makes the base the same, which base the same, which makes it 0, plus 19, which makes x equals 19. Gotta change the format. I know what you have to take, but I know that you have to take the ln of both sides. Where do you see ln on both sides? I don't see ln on both sides. So the first thing is, if you know that this guy is basically log based E, that means, first of all, you can keep this here because that's the exponent. So you can rewrite like this, right? Because as I said, you can write the exponent in front, right? So you can write like this, x times ln E, and as your base and variable is the same, the logarithm which with respect to which you are operating. So it means x times 1 equals 19, x equals 19. That's it. That's your answer. As long as you know that this log is log based E, you can clearly use this property where this is 1, right? So again, as I said, if you know the properties and if you know how and when to use that, you can see you should be doing all right. Okay. All right, next. Question 1, okay. Question 1. Oh, before that, you might be wondering that if there will be a question from 11.2 or not. So it was not possible to generate a quiz question like this, which I have given to you for the review, or rather as the review materials. So that couldn't be done. But as I said, only the appendix and the section 1.4 will not be there. Other than that, everything is uh, in the syllabi for the test, okay, for the final. You need to practice everything we have covered. Well, that's what I said. There is no review material for 11.2. Just use the lecture I have shown you, okay? just use the materials you have for the resources. You have a PPTX file for 11.2, use that, see my videos, okay, and that should be enough, okay. All right, so question 1. Yeah, question 1, you don't need to do that, okay. Next one is number 15, okay, number 15. Okay, find the domain of the function. Okay, that's a very good question, because as I said, there will be questions asking you to find the domain. That's for sure. I'm actually giving you the question. That may or may not be for a logarithm. That may be for a polynomial. That may be for a fraction. But definitely you'll have questions where you will be asked to find the domain. Okay, so it's really important to know these steps. Okay, how to find domain for any function of any format. It's really important to know that. As you are approaching for the final, it's really important to know this. Okay, so let's try number 15. Again, I'll take answers from you. So h of x is 3 minus log 9 log rather base 7 x by 9 minus 2. Okay, so that's the function. Obviously, that's a logarithmic function, right? That's a logarithm. And again, I'll take answers from you first. What should you do when we have a logarithm in our hands? How to calculate the domain? What's the general idea? Anyone? What's the general idea? Just don't go for this one. Give me the general idea. Whenever you are given a logarithm, what's the general idea to calculate the domain? Let's say I have a log x base a. What could be the domain of this? Can x be 0? You said x can't be less than 0. Can it be 0 precisely? Okay, so if you plug in log any base, doesn't matter, any base log 0, can you tell me what it shows as the answer? Just use the calculator. Exactly. Log can't be 0 either. It has to be strictly greater than 0. Okay, that's why I said go for the general idea first. Okay, so the general idea is this x needs to be strictly greater than 0. Okay, it can't be 0. It has to be more than that. So whatever you have, this guy needs to be strictly greater than 0. All right, so x over 9 minus 2 has to be greater than 0. If you solve it for x over 9 greater than 2, I'm just changing sides for this. So x will be, if I change sides for this, x will be greater than 18. And what it means, well, look at the instruction. It says type your answer in interval notation. Okay, again, look at the question very carefully, because it might say it might actually give you this x, and then it will leave a blank here, and then you need to write greater than 18 or something like that. It might give you a question like this as well, but on this occasion it says write using the interval sign, And as it's strictly greater than 18, it will start from 18 and it will go up to infinity, right? Not including any of those. So yeah, as Daniel have written, 18 to infinity, open on both sides. That means we're not really including those two values. All right. Okay, next. 16. Okay, I think I have one question from Daria as well. Number 3 and 4. Let me see that. Number 3. Okay, you don't need to do number 3. For number 4, graph one-to-one function. Okay. What is shown to the right? Okay, okay. So the graph is given and you need to draw the graph of the inverse. Okay, so when you are given a function which has a one-on-one correspondence, that means which is a one-to-one function, for the inverse, you just need to take the mirror image of that in terms of the y equals x line, okay? So that means that's the y equals x line. Whatever you have as the graph of the main function, just take the mirror image of that. So we have, oops, sorry. Something like this, right? Oh no, it will actually cross the y-axis anyway. So yeah, something like this. Okay, so that's your y equals x line. And as I said, you need to take the mirror image of your graph in terms of that line. Okay, so let me show it one by one. If you are just confused, how am I getting this? So I'm just taking this step first, okay? So for this line, as on my left to this y equals x line, this is going to the negative infinity direction in this fashion. So on my right, it should behave like this. Can you see that? Just take the image of that portion, okay? Let's forget about anything else. If you have a mirror here, let's say that's a mirror, okay? Let's say this blue line is a mirror. You just need to take the image of that. So if it behaves like this, on my right, it has to behave like this, okay? That's the first part. What about the second part? So on my right now, this time I'm working on my right to the, with respect to the y equals x line. So this is behaving like this, okay? If you take a mirror image of that, it should behave like this, right? Can you see that? Just forget about everything else. Just consider that portion. Can you see the symmetry here? Right? Does it make sense? So finally, your graph will actually look like this, right? The white line, right? Very good. Okay. Okay, so next, we don't have to do 7. Okay, let me see 7. No, you don't have to do 7. Yeah, that's right. Okay, problem 16. Problem 16, where is that? Okay. Okay, let's try problem 16. Okay. So we have natural log, the 6th root of, is it E? Yeah, it seems like that. It's E. Okay, again, I think I have just showed you a problem like this. It's quite similar. Just give it a try. Just try this using the same problem. Let me give you a hint. It's exactly the way I've done this one. Try it. Give it a try. Sorry, I am just turning off the air conditioner. Anyway, so for this problem we have, again, we need to write this in a format where we can use the properties we already know. So obviously this could be written as e to the 1/6, right? Again, if you have, if you have nth root, you can always rewrite that as x to the 1/n. So I have just done the same thing here, right? And again, if you know the property, you can write the exponent in front. And what's the value of this? Anyone? 1. Very good. So it will be 1/6 times 1, 1/6. So that should be your answer. Okay, that should be your answer. Okay, what's next? Number 13. Okay. Number 13. Okay. Use properties of logarithms to find the exact value of the expression. Do not use a calculator. Okay, again, that last line doesn't really make any sense, because even if you use a calculator, no one is going to find that out. There is no way we can trace that. But obviously, for your betterment, for your future journey, it's really important so that you know this. No, you have to do this. You can do number 13. Why not? You can definitely do number 13. When did I say that you don't need to do that? Again, as I said, you can use calculators. That's what I said. But for your betterment, for your future journey, if you know how these stuffs are done, because this semester you are going online, but in future, this will not continue. And in Math 181, if you take that, calculators will not be allowed. So you need to know how to actually solve problems like this, how to rewrite these expressions, how to find or approximate the value, etc. Okay. All right. So number 13, it's log 4 base 3. It's log 3 base 4 and log 16 based 3. So we are trying to find the value of this, and obviously without the help of the calculator. What's the first thing comes into your mind when you see a problem like this? What can you do? Make the basis same? I don't think that's a feasible option, because we have a 4 here, that's a 3 here. I don't think that's a feasible option. Combine them. Okay, someone said combine them. If you want to combine them, what should you do? So first of all, if you want to combine a particular, yeah, you can combine that just multiplying these two, right? But for that, your base needs to be same. Oh, is that a, oh, sorry. Did I write a, oh, I saw it wrong. That's a product instead, my bad. Sorry. Okay, we can even do that with the plus, no worries. Anyway, let me show the exact problem. So if you have a product, okay, now it makes sense. What you can do is, first of all, Okay, yeah. So first of all, we can write log 3 base 4 times log 3 base 4 squared, right? 16 can be written as 4 squared. Okay, next 4 base 3 times, we can actually take this in front, so it will be 2 log 3 base 4. Okay, all right. So these two can be taken here because we are multiplying. So this is exactly the same thing even if we write it in front of this. Okay, now can you see any relation between these two logarithms? Can you see anything what I can do? You actually know a property for this. First of all, can you see anything? Any relation, any symmetry or any asymmetry, any relation which is catching your eyes? What I can see, first of all, is this. We actually have to deal with the same values, same numbers, I should say, but in the opposite order. Can you see that? It's log 3 base 4 and other one is log 4 base 3. Can you see that? So you have a formula or property like for this type of problem. And that is, if you remember, sorry. That's it. It's actually the same thing. Okay, the reciprocal of that, but obviously the order will get altered. Okay, as you can see, it will change its position. Okay, so we can use that property for either of these. Doesn't matter. I'll use this for the next one. So it will be now log 3 base 4, and we can cancel this. So our final answer will be 2, right? So that is your problem. All right, what's next? What I did was log 3 base 4 times log. Okay, it's really difficult to understand because I understand that you can't really write the base. Okay, so I'm going to avoid it, which cancels out log 4 base 3 and leaves you with log 4 base 4 squared, which then became log 4. I'm not sure what you did there. If you can send me a picture of it, you can actually send this in this chat section as well. I'd be able to answer you better because I'm not really sure that your method was right or not. Okay, I need to verify that. There could be 2 different ways to solve this, even more than that, no problems with that, but I want to see what you did there because it could be wrong. Okay, even if you got the answer right, doesn't matter, your process was right. Although for this type of exam, you don't need to show your work, but again, if your process is wrong, for other problems, your answer could be wrong as well. So I would like to see the work you have done for that, okay? You can send me email, you can send it here in the chat section, whichever you like. Okay, so 17. Okay, number 17. Okay, so first of all, what's the domain of that? Can you tell me what's the domain of an exponential function like that? So that's number 17. Oops. So your function is 5 to the x plus something. Let me recheck it. What's that? Okay, plus 4. Okay. What should be the domain? Negative infinity to positive infinity, exactly, because there is no value of x which is making this undefined, right? So definitely the domain will be from negative infinity to positive infinity. Okay, I'll check that work after we finish this problem. Okay. Next, what's the range? Okay. Next, we want to see the range of this. So how can we calculate the range? What should we do? Obviously, the range is the value of y, right? For range, what should you do? Can you see any way, any method you can use here? Anyone? None at all? Find the horizontal asymptote or shift the graph up 4. Okay, so first of all, if you just take a look at this, what could be the value of 5 to the negative infinity? I'm just showing you one naive approach, okay? What's the value of 5 to the negative infinity? Do you know that? It will be 0, okay? So if you just take the lowest possible value of x, you still get y equals 4, okay? And as you increase the value of x, that means this guy, you will see your value will slowly and slowly go to the upwards direction. It will go upward, okay? It will never go below this value 4. It will never go below that, okay? And obviously, this is not a value we can take, because as you can see, that's the parenthesis. That means it's not really included, but we can go really close to that. We can approach to negative infinity. We can go very close to that, but not quite to that negative infinity, right? So even if you go to negative infinity, you still see it will actually be 4, okay? So if you not go to infinity, if you approach that, that means your value will approach 4 as well, okay? That means your value will never cross 4. It will never ever cross 4. If you just take infinity, only in that case it's giving you a 4. So that means your range will be from 4 to infinity. And you can see it's not included. It will be actually bigger, it will be actually more than that, more than 4. Because you'll get 4 only if x is negative infinity, which is not a defined case, of course. We'll go very close to that. So it will be very close to that 4, but not quite 4. Okay, can you see that? So it will be from 4 up to infinity. Are you guys with me? And clearly it answers our next question as well, which is the horizontal asymptote. So the horizontal asymptote is obviously at y equals 4, right? Because this graph will never cross that 4, never ever cross that. It will go very close to that, but it will never cross it, right? And next question is, what is the y-intercept? Okay, so for y-intercept, we know we just plug in x equals 0, right? So 5 to the 0 plus 4, 1 plus 4 is 5. So that should be your y-intercept. Any question from this? All right, let me see. Okay, so log 3 based 5 and log 45 based 3. So you can write it so first of all, for your convenience, you're taking the base as 5. I understand. 5. Okay, so it will be 3 based 5 and 45 based 5. Okay, and you're canceling the term with 3. So it leaves you with 5 and 9. Okay, and okay, so again, that's even a longer process. I think that's all right, because you can take any base as you want, as long as they are same, but it doesn't solve you the problem. So I'm not sure whether it's a good idea or not. Anyway, yeah, all right. Did we learn about the rational zero? Why is that? I need to see the question first. It does, because log 4 based 4 is 1. Yeah, that's right. And I had 2 log 4 based 4. Okay, yeah, I understand. Right. Okay, where is your rational zero theorem? Where did you see that? Which problem is that? Anyway, what's next? Chapter 4, question 6. Okay. What's next on your list? Chapter 4, question 6. Question 6. Yeah, rational zero is actually the way we have found out the real zeros. That's actually the rational zero theorem. Yeah, you have seen that. So for rational zero theorem, that means you are trying to find the real zeros. Okay, that means you want to work on the factors of the constant term, plug it back into the main function to see for which factor you'll get a zero, and that will be a real zero for you. Okay. Oops, sorry, because of inactivity, I guess the screen sharing has been deactivated. So let me start that again. Okay.